Well, thank you for inviting me. This is really an exciting meeting today, and thanks Alyssa and Jan, because they've done most of my work for me. I could really just stand up here and be quiet for 15 minutes, and hopefully that would be fine. I moved to Singapore about 9 months ago. I've been working in the aging field for 2.5 decades or more now, and I really feel like that this is one of the best places to try to do something about human aging. So I'm going to try to convince you of that today. This is life expectancy over the last 40 years or so. So we're looking at 1970 versus 2010. And one of the things you'll note is that life expectancy has been going up quite dramatically. You know, people for years have been telling me, well, why work on aging? You can't do anything about aging. And I think, as Jan mentioned, this is probably not the case. It might be surprisingly easy to affect aging. And if you measure that by life expectancy, at least, it's gone up quite dramatically. But there's one other point I want to make, is that one of these lines does not look like the others. The United States and Japan had almost identical life expectancy in 1970, longest in the world probably at that point. And yet, now they're dramatically different. And so the lifestyle, the social factors, the health care, all of these things can influence life expectancy. And in the US, we have particularly bad habits. I will say, Alyssa, that if you keep talking about reducing iPhone use and reducing Coke, you may be looking for a new country soon, and if you'd like to come to Singapore, just let me know. But those things have a big influence. We're overeating in the US, we're overstressed, and we have a healthcare system that doesn't balance very well to deal with the people that are poorer in the population, and this is the effect of that. We're now 50th in the world in life expectancy in the US. Now in Singapore, not just are they thinking about life expectancy, but you have a low birth rate. And so what's happening is, if you look at the number of people that are working compared to the number of people over the age of 65, that's declining rapidly. And by 2030, we're going to have 2.1 people working for every retired person here. And the government has paid attention to that. So this is not just about the quality of life as you get older. This is an economic effect. This can impact the functional output of a society. And so I think that I want to re-emphasize this point that's already been mentioned, that there's a big difference between lifespan and healthspan. And these are my two grandmothers. So this is Eliza here on the left and Lita on the right. They both lived a very long time. Eliza died at 99 and Lita at 101. But they had very different life trajectories. And so Eliza, when she was 60, the doctors said, you've got all kinds of problems, and I don't think you're going to live for 5 more years. Well, she outlived that doctor and 2 other doctors on the way. But the problem was she was very sick throughout this. She had osteoporosis. She had very bad problems with rheumatoid arthritis. She had dementia at the end of her life. And she was taking 15, 20 pills a day throughout the last 2 decades of her life. Now, she had one thing going for her that I think was very effective, and that is she was very stubborn. She was not going to let anybody tell her what to do, and I think that probably positively impacted her life. And I will mention that Jean Calment also had that. She did an interview when she was 112, something like that. And the journalist said, are you concerned about all these wrinkles that you have? And she said, Madam, I only have one wrinkle and I'm sitting on it. So there is something for stubbornness. But Lita here lived 101. She was living alone at 101 in her house. She quit driving at around 95. I thought she was still doing pretty well, actually. She bowled a 238 game at 93. She sent me the little wax score sheet and said, see if you can beat that. I think that this is what we really want. She was healthy her whole life. Her heart valves gave out and 3 months later she died. That was sad, but this is what I want. This is the compressed morbidity that we're talking about here. And this is the problem we have right now. Life expectancy is going up dramatically. We already showed this for Singapore, but here's another way to look at it. If between 1990 and 2010, if you're a male in Singapore, you got a 30% return on investment. For every 3 years you live, you can expect to live 1 year longer. but healthy life expectancy is not going up at the same rate. So the effect of this is that we're keeping you alive longer, but we're keeping you sick longer. And it's this difference that's where all the healthcare costs are. And it's this difference that's the quality of life effect. This is when you're sick is when quality of life is declining. So what can we do about this? And if you look at what's causing disability-adjusted living years, there's really three different factors. There's communicable diseases like HIV and a range of other tuberculosis and other diseases. There's accidents and injuries and falls and things like this. But there's this big blue box here. This is 65% of the global healthcare costs in this big blue box. What is it? Well, look, heart disease, stroke, cancers down here, Alzheimer's is here, COPD, diabetes. You could take all of these labels off and replace it with the label aging. It's the biggest risk factor for almost all of these things in these blue boxes. And yet we don't think about that. So this is my version of the slide you've already seen a couple times, is that this is the biggest risk factor here. Why don't we focus on targeting this instead of just only taking one disease at a time and trying to treat that disease? We might have a much bigger impact. Let me illustrate this a little bit more directly here. Okay, so this is the Framingham Heart Study. Okay, so we're looking at your risk of cardiovascular disease, and there are all these columns here, and you get points based on where you are in these columns, and you add up the points at the end, and that's your cardiovascular risk. All right, so now we're going to compare two people here. This is a little bit simplified, all right, but I think it illustrates the point. The first is like the most unhealthy person you can imagine. They're 32 years old. They have low HDL. They have high cholesterol overall. They have a high blood pressure. They smoke a lot, and they already have diabetes. Now, if you take the time to add up all these points that they get for each column, they get 15 points of risk, okay? Sounds like a lot. It is a lot. All right, let's compare that to the next person. This person is the most healthy person you've ever met. They're 77. But they have reasonably high HDL, they maintain their cholesterol low, low blood pressure, don't smoke, don't have diabetes. They sound like they're doing great, right? Add up the points, 15 points. The same amount of risk that the unhealthy younger person has. So we talk about cholesterol, and we aggressively treat cholesterol. If you come in and you have high cholesterol, you're going to get something to take for it. We don't say, you don't go to the doctor's office and have them say, oh my gosh, you're 73, we need to do something. But this is probably where the biggest impact is. Okay, so let's rethink the basics. Aging-related chronic diseases and functional decline are the biggest challenges of this century. Aging by itself is the biggest risk factor for this increase in chronic disease that I'm talking about. And so, why don't we change what we're doing? Why don't we address aging? Because that will have the biggest impact by targeting multiple age-related health issues at the same time. Sounds like common sense, but it's been very hard to try to achieve this goal. And that's really what we want to do. So this is really the only mechanistic slide I'm going to show you, and I'm not even going to talk about the mechanisms that much. So there's 7 different things in this particular paper that were mentioned to drive aging: changes in metabolism, damage, epigenetics, inflammation, adaptation to stress, proteostasis, changes in proteins and how they fold in the cells, and the ability of your adult stem cells to regenerate tissues. And if you look at things like telomeres impact a whole number of these different factors. But I don't think it's necessarily what we decide drives aging. I think the important thing is that how this is networked together. All of these things influence each other. So if you have altered metabolism, you're pre-diabetic, it influences inflammation. And that influences adaptation to stress. And that influences damage. So this is a network. And when you're healthy and not sick, you have this dynamic network that is maintaining the homeostasis in your body. But when enough of things go wrong in these different areas, it starts to trigger a disruption of the network, and then you start to get chronic diseases of aging. And so what we know now is that you can intervene at a whole range of different points here and impact the aging process. So these are different interventions, thank you, that can impact aging. calorie restriction, which is essentially a reduction in calories down to the level that's above malnutrition but nothing extra. I don't recommend this for people because it's very hard to follow this kind of a dietary regimen, but it's very effective in animal models for extending lifespan. There's great data already on exercise for human aging. We don't have to talk about animal models there. Intermittent fasting is quite exciting as well. Actually, low levels of alcohol consumption are associated with reduced mortality, and I can talk to you about that. We're studying that in mice now. We have mice drinking 10% ethanol in their water all the time. They seem happy, actually. And then there are a whole range of different drugs. And my lab works predominantly on rapamycin and the TOR pathway, and you can come talk to me about that if you're interested. But a lot of these drugs are things that people are already taking. Metformin, which people take for diabetes, NSAIDs, acarbose, another diabetes drug. There's a whole growing list of things that may impact human aging. All of these work in animal models, but we don't really know about humans. So the idea is to come to Singapore is to set up a Center for Healthy Aging in US, but we're also collaborating with Yong at Yale in US and people at Duke in US as well. Our main goal is to deal with human aging. And I think the challenge is right here. So we've been telling you about aging research. And so if you're born, you start to get sick, and then you die, what we've been able to show, and what Yong showed, is that if you intervene here while you're still healthy, you can lengthen this period of health span, stay healthy longer, and increase the ratio of health span to lifespan. But the geriatricians haven't been doing that. The people that work with older people in the hospital are not thinking about intervening here. They're dealing with people that come in at 85 years of age. They have multiple chronic conditions. They're taking 15 pills a day. They're having trouble getting out of bed. They're not eating enough nutrition. They're trying to manage aging. And this is important. I'm not trying to diminish what geriatricians do. It's critical. But the challenge is, now that we want to go into humans, how do we take this knowledge we have from preventing aging and merge it with the expertise that geriatricians have from managing aging to take a holistic strategy to target human aging? And ideally, the approach is going to be a mix of the two. We want to prevent aging as long as possible and then manage it effectively when people get older. And so this is the goal, to extend human health span in Singapore, to identify and de-risk interventions, test them in people maybe 55 to 65 that are still healthy or at risk of disease, validate that they work, and then develop implementation strategies that might work in the whole island of Singapore. And we're going to look at short-term studies to try to stratify different interventions using biomarkers, 3 to 6 month studies, and try to measure now with molecular biomarkers whether we're impacting aging. And then ultimately we may move to more medium-term studies where we're taking people at risk, treating them for 1 to 3 years, and then trying to prevent multiple diseases of aging simultaneously. Now, we talked a little bit about intervention, but the other cool thing is that biomarkers have emerged. You heard about telomere length, but there's a whole range of different biomarkers now of aging that are partially validated. And so now we have things we can start to test. When we look at an intervention, how does it impact these biomarkers of aging? And I think each of these are probably measuring different or overlapping aspects of aging. So we probably need something like this, where we have a platform of integrated biomarkers, which we can take from a blood sample, maybe from a stool sample, and we can integrate them together to get a biologic measure of your age. And then we can look at how interventions affect that. And I work on drugs, but I'm agnostic to the intervention. I think that lifestyle intervention, I'm totally supportive of mindfulness. It's hard to study in mice, but I'm totally supportive of that. But I think that what we need to do is have strategies to compare mindfulness, to compare better sleep quality, to compare diet, to compare drugs and supplements, and maybe stem cell regenerative medicine strategies, and see how do these impact these different biomarkers, which ones work better for which biomarkers, and ultimately which diseases of aging. And there's probably going to be some combined strategy that we recommend to people ultimately for how they impact their aging process. And it's also going to be personalized. I don't think that one drug is going to work for everybody. We need to know how people are aging in a personalized way and what we can do for them specifically to extend their health span as long as possible. So I'll just close And I put this term up when I started the center, healthy at 100, and a bunch of people have said to me, wow, that's really aggressive. That's, healthy at 100, how are you ever going to achieve that? And so I want to just leave you with this concept that if we mostly fail at this and we end up with not bad at 90, that's still going to have a much bigger impact on health and function and the economy of various people in the countries they live in than trying to develop the next cancer drug that's going to extend somebody's life 3 months of age and cost a fortune. This is really a revolution in medicine. We know how to test it now. Some of the strategies we have are going to work. We have to figure out a way to identify those strategies and implement them to keep people healthy. So thanks.